Welcome to this lecture. In this lecture, we'll solve the numericals from resistor noise in the tutorial 7. The first question is, the input noise voltage of an amplifier at 100 MHz is given as 3 nanovolt per root Hertz. Calculate the average power in a 1 Hertz bandwidth at 100 MHz. So the quantity given is input noise voltage and the unit is volt per root Hertz. So the quantity given is, so we know that SV of F, that is voltage noise spectral density, unit is volt square per Hertz. So the given quantity is actually root of this. SV of F under root is given as 3 nanovolt per root Hertz. This is the quantity given. So from the units, you should identify the given quantity is root of power spectral density. Now the question is to find the average power in a 1 Hertz bandwidth at 100 MHz. So average power is equal to, average power is nothing but Vn square bar, which is equal to SV of F into delta F, where delta F is 1 Hertz and SV of F is actually square of this. So this is equal to 9 into 10 power minus 18 volt square. Answer is. Now your second question. Second question is, calculate the voltage noise spectral density of a 50 ohm resistor at 300K. So 300K is again room temperature. The resistor value R is equal to 50 ohms. Now voltage noise spectral density is actually SV of F, which is given as 4 kTr whole square per Hertz, where in the lecture we have seen KT value at 300 Kelvin is 4 into 10 power minus 21. So this is equal to 4 into 4 into 10 power minus 21 into 50. So if you solve, you'll get 8 into 10 power minus 18 volt square per Hertz. Now the third question, calculate the RMS value of thermal noise of a 1 kilo ohm resistor. So 1 kilo ohm resistor measured by an oscilloscope of 100 MHz bandwidth. So the bandwidth of oscilloscope is 100 MHz, resistor value is 1K. RMS value of thermal noise. So RMS value of thermal noise is actually, so what we know is this is average power. So RMS value means it should be average power only. So average power Vn square is equal to SV of F into delta F. Now what is SV of F? Which is 4 kT R multiplied by delta F. So this is equal to 4 into 10 power minus 21 into 1 kilo multiplied by, here the bandwidth is actually 100 megahertz. So it is 100 mega. So which will be equal to 16 into 10 power minus 10 V square. This is the average power. The question is RMS value. So RMS is actually under root of Vn square bar, which is equal to 4 into 10 power minus 5 volt. Which is equal to 40 microvolt. Now this fourth question, calculate the equivalent noise voltage of two parallel resistors R1 and R2. Equivalent noise voltage, it is Vn square bar. So equivalent noise voltage we can express in terms of power only. So Vn square bar is equal to In square bar into R square. If you are Vn square, you can write Vn square bar as 4 kT into R. This is what we know about the average power. This is actually the average power. What is R? Yeah, so if you look at this circuit diagram, there are two resistors in parallel. So both resistors are actually noisy. Then only we can find the noise power. So I can represent this noisy resistor as a noiseless resistor in series with the voltage source, and here also series with the voltage source. Right. So this can be, so here R is actually the equivalent resistance of R1 and R2, which is R1 parallel R2. Right. So this is Vn square bar is equal to 4 kT into R1 parallel R2. Or if you want to express in terms of current, it is 4 kT by R1 parallel R2. So in all these problems, basically there are two formulas or two things to remember. One is your power spectral density SV of f, which is given as 4 kT or V square per hertz, and other one is average power, which is given as 4 kT or V square, and the relationship of these two, Vn square and SVF, is equal to SV of f. This is voltage noise spectral densities Vn square bar by delta f. So we'll continue in next lecture. Thank you.